Hi, my name is Mano Marks. This is the third in our Google Geo Developers Workshop series. And I am pleased to introduce tonight Randy Sargent and Ted Morse, who are from GigaPan, and they're going to be presenting about photo overlays. In 2005, Randy Sargent started the Global Connection project with colleague Ilya Norbas, and with the goal of helping us learn about and meet our neighbors across this globe and learn about our planet itself. I'm obviously reading this, but I did know this. I'll throw in these little asides just to make everybody more comfortable. Past work includes founding 2 successful technology companies and helping develop Lego Mindstorms while earning his master's from MIT's Media Lab. Ted Morse has been at NASA as an intern since 2004 and has been employed by the Global Connection Project since earning his bachelor's in science in May of 2007. Past work has included parts of NASA's K9 experimental rover and extensive use of KML for various facets of the Global Connection Project. All right, so Randy and Ted, take it away.
Thanks. Are you getting me okay on the audio? Great. So let me show you first. This is you guys may recognize is where we are. If I can find my mouse, it's fun to zoom out a bit here. If you haven't been on top of this hill, you should go over there when we're done today. The view from up there is spectacular. There's kind of a small hill here, but the tall one over here. Go up there. It's great. If we keep zooming out, you'll see right across Stevens Creek here is NASA Ames, and this is where Ted and I hang out and where we do most of our work. One of the things that we do at NASA Ames is we work on software for stitching and viewing very large panoramas. And I want to ask why would we be doing that sort of work? And let me show you a picture. We work on a number of different Mars rover prototypes at Ames, but this one is the real thing. Let me bring it up. This is the Mars Exploration Rover. And when the 2 of these landed, I had the honor to go to JPL and help out with some of the image processing there. And we had lots of very interesting images coming back. And I want to show you one of the images that came back that was stitched together at JPL and Cornell, and we had a little viewer that would take this and let you go explore it. One moment while I fumble my windows. I apologize. Here we go. So this happened about 100 days into the mission for the second rover opportunity. It steered into a fairly large crater, and what we're seeing here is actually the cliff called Burns Cliff, which was stitched together out of roughly 100 pictures. And let's go exploring this. You can see a little bit like Google Earth or Google Maps. We can go zoom in, and what should be happening is that those images should be streaming over the internet connection and giving us more detail. However, I think that my network's actually not working. So it's still doing DNS lookup, which I take as a bad sign. One moment here. Let's see if I actually have a network or not. No. Well, I'm getting ping times of 2 seconds. That is.
Are you on Google Guest?
I am on Google Guest, yes, with 2 bars. Is there something better I could try? Let me turn it off and turn it back on and see if that works any better.
I've got pretty good signal strength, so
okay.
maybe just reconnecting.
Yeah.
Might try slightly shifting the laptop in case the antenna's in some kind of void.
Yeah, it could be. Okay. I'm still getting packet drop. Let's try. That works better. Okay. Go figure. I feel like I feel like back in the days of antenna TV when you like move your TV antenna around. Okay, let's try this again. Okay, so now, this is what I expect to be happening. So as I zoom in, you can see all the different rocks here in the wall of the crater. You can see some fairly interesting layering, and the layering was one of the things that the scientists were looking very closely at. We can go looking around all different parts. You can really spend maybe 20 or 30 minutes just on this one image exploring and looking for different things. As we get a little bit closer to the rover, you'll start to see these funny little spots. And let's get a little closer and maybe zoom in a bit. And these guys are actually spheres that are maybe 3 to 5 millimeters in diameter, which the scientists were nicknaming blueberries. And they're one of the things that the scientists believe were produced with water, as water would seep through the rocks. Go explore some more. You can recognize these are the solar panels on the rover. And as we look over here in the distance, see these funny little marks, which are evidence of some sort of intelligence on Mars. These are actually the rover's treads on the way to the position it's in. So we can follow these back in the distance and see where the rover came from. So this is the sort of thing that we were working on a few years ago. My machine is having trouble here. I'm going the wrong way to get the mouse off. There we go. So that's what you do on Mars. I mean, on Mars, all you get back are images and other science readings. So the way you're going to go and explore has to be all through these instrument readings and images that come back. Well, what about Earth? Why would you do the same thing on Earth? Can't we just travel ourselves and go see things in person? We can't do that on Mars, but we could do it on the Earth. It turns out that people don't. Travel is pretty expensive. Not everyone can afford to do it. In fact, if you look at the stats for people in the U.S., only 15% of the people in the U.S. have ever traveled abroad, which I found a shocking number when I found it. But it's important that we're learning more about the world because we're increasingly facing global issues. So let me forward through. I think some of you weren't alive when the Clean Air Act got signed into law. But in the late 60s and early 70s, the U.S. recognized a problem with all sorts of pollution in the air. And this is a picture of Los Angeles with its kind of signature smog. Well, the smog was really bad in the early 70s. And people in the U.S. decided, well, let's pass a law, the Clean Air Act. And as a result, a lot of people spent a lot of money to reduce the sort of pollution that creates smog. Gasoline was reformulated. Cars got catalytic converters. It cost a lot of money to do this. So people were willing to respond to this problem in that way. But let's fast forward about 30 years and look at carbon dioxide in the air. There's a big difference between, smog like nitrous oxide in the air and carbon dioxide. It turns out carbon dioxide is a global problem, not a local problem. So smog, you produce it, it goes away pretty quickly, so it's going to tend to affect the places that emit it. Carbon dioxide isn't that way. So we had this real issue. Well, do we want to spend the money it takes to start reducing carbon dioxide in the air? So it's the argument of our project that we need to learn to become citizens not of our cities or states or countries, but citizens of the world. We need to start thinking with a more global outlook to be able to address these resource issues which are coming our way. Carbon dioxide is one of the early ones, but there are a number as our population grows larger and our ability through technology to impact the world grows. We're going to run into more and more of these issues. And we need to start changing the way we think about our planet. So we thought, well, hey, can we take what we're doing in Mars and apply it to the Earth? So we said, let's make a device which captures high-resolution panoramas cheaply. So here we go. After a few years, we developed this device with a company, Charmed Labs. So you can see it up here. You just take your standard digital camera here, and you attach it on the arm, just right here. And this device basically takes the place of the $1 million cameras on top of the Mars rover. It can pan, it can tilt, it doesn't do stereo, it doesn't do 16 different bands of light, but it does work for visible, which is what humans mostly care about. You'll see that it actually has a little appendage here. This is the finger that actually presses the button on the camera. In an early version of this device, we actually talked to the cameras over USB, and it turned out that taking the laptop out into the field, in bright sunlight, just wasn't very workable. So we found that this was the one interface which works with all cameras. So let me show you just real quick what it's like to operate this thing. So I turn everything on, I click on New Panorama, I set the camera to maximum zoom, and I press OK. And now it's going to ask me what's the upper left of the panorama I want to get. And I'll kind of point it up here. I'm going to get, say, from here to here. Now let's set the lower right. Go right there. And it's telling me it's going to be 13 pictures across by 9 up and down. Now, I'm not going to publish this one, so you guys don't worry. You don't have to smile, unless you want. But we'll set that, and we'll say OK. And it's going to start taking pictures now. Oh, actually, no, I take it back. It's showing me now the four corners of the panorama. I clicked on OK there. So it's showing me the upper left, the upper right, lower right, and now it's going to show lower left. And it's going to show us just the center, which is a little bit gratuitous. Doesn't mean a whole lot what the center of the panorama is. Okay, now it's asking, do I really want to take the 117 pictures? I'll say yes. And now it's asking me kind of the dummy list so that I remember what I need to set on the camera. It says, is the camera turned on? Yes. Is the white balance locked? Yes. Is the exposure locked? Yes. Is the focus locked? Yes. Is the flash turned off? Yes. And it's taking the panorama. So now it's going to start taking those pictures. And I'll let that go while I continue to talk.
So if I smile and then frown and kind of alternate, do you think I can get a smile at the the low zoom level and then a frown at the high? No,
what happens is that all the images that it takes, and I'll show you in a little while what it looks like to have these pictures that overlap. It's going to, let's say that your face was in more than one picture. It's going to kind of pick a boundary between those images when it stitches them together. So you might get your smile completely in one, or your frown completely in one, or you might have kind of half of your mouth in one and half in the other, which can look a little bit awkward. So let me start flipping through some more. So this device here can take panoramas typically between 50 and 1,000 images. It's theoretically possible to do a significant number more than 1,000, but we tend to lose patience around 1,000. That takes about 30 minutes or so. The stitching application can then go and combine all these images to produce very large panoramas. So the panorama you saw of Mars is about 50 megapixels. We can stitch with the stitcher anything from 50 megapixel on up to 5 gigapixels and beyond. This is a screenshot of the stitcher. This is a panorama that Ted will show you in a little while. I took this a couple weeks ago in the Swiss Alps, and this is just a very small part of it. But what we've done is we've loaded up all the thumbnails of the images in that panorama, and if I showed you the whole thing, it would be over to here. It's roughly 900 pictures for this one. And you'll see, if you look closely, that there's overlap. You'll see like this little piece here is the same as that piece there. And that's what happens when you have the images that overlap somewhat. It has to figure out, well, how do I going to combine those? So let me go. Actually, I think for the crowd here, let me explain a little bit more detail exactly what's going on there. So it turns out on the cameras that are on the Mars rovers, they're extremely accurate. You know this. They're machined out of single blocks of aluminum, and they point very accurately, and they're relatively low resolution compared to these cameras. These cameras see more pixels, but they have little pieces of plastic in them, so I can wiggle this back and forth. The tripod's not so steady. There are a lot of problems that cause a misalignment between adjacent images. So it turns out that while for Mars we could kind of get away with knowing what direction we were pointing and having this very accurate model of the camera that JPL developed for these things, here we actually have to find the optical features between each pair of images to line them up. Now, because we're taking these very narrow field of view images, it's very common to have either in the sky or the side of a building a pair of images which have no discernible features at all. So one of the things that we do there is we, from the other image alignments that we can find, we deduce kind of what the geometry of the GigaPan was. We deduce exactly what angle the camera was screwed onto the top, what the pan delta was and what the tilt delta was, so that we can roughly place the sky images in probably plus or minus 5 pixels, but if there are no recognizable features, no one notices if the sky is 5 pixels off. So that's kind of what's going on under the hood in the stitcher.
So your stitcher doesn't know anything about the mechanics of the panorama taking device.
So that the stitcher understands that things are taken in a grid. What it doesn't know, because it's not recorded in a way that it will get the information, it doesn't know what that this one was set up to pan every 5 degrees and tilt every 3 degrees. And that's going to depend on what your camera was zooming to. So this camera can zoom to a very high zoom level. Other cameras might not be able to zoom so far. So different times you set up the GigaPan, you'll actually pan and tilt different amounts. So it deduces that from the actual image features. So let me show you now some of the panoramas that we've been shooting with this. See if I can have a complete blue screen. What does that mean? It's blue on both. Oh, here we go. Hold on. It's teasing me. Come back, come back. I really want to talk to you. Okay, let's... maybe I quit out of PowerPoint. Maybe that's safe. Oh, this mouse is freaking out. Oh, that's better. Okay. So everything like somehow popped to my main monitor here. Okay, let's try this again. So one of the first panoramas that we took is of the Grand Canyon. So let me show you that. You'll see there's a lot of detail here. And this was taken in the winter. So you can see snow, and I've been to the Grand Canyon before, but I haven't actually seen it in snow. So to me this was incredibly fascinating. You can see the amount of detail is pretty significant.
Does the camera automate the zooming as well, or do you have to do each zoom level?
So what happens is you actually set up the camera kind of manually. So you'll select the zoom level,
Right.
and if it's kind of a normal camera that maybe has a maximum of 3 or 4x zoom, we just suggest set it to the maximum and just leave your GigaPan calibrated for that. If you have a camera that's maybe maxes out around 10 or 12x zoom, then we suggest that you kind of select on a case-by-case basis, because sometimes if you're taking a 360 and you're at 12x zoom, you might be taking a panorama with 5,000 images, and you might not have enough patience or battery for that. So if you have the higher zoom cameras, you'll end up kind of adjusting the GigaPan depending on what zoom level you've selected. There's a little calibration menu where you set it up, and you kind of line up things at the bottom of the image and line up the same thing with the top of the image, and it deduces from that how many degrees were in the panorama.
So you're not actually taking images at every zoom level. You're scaling them for.
Correct. So we take all of the images at full zoom, at the maximum zoom level, and then from that we're actually going and computing this thing called an image pyramid that Ted will talk about, which is something that we use both for our own display and also for display in the photo overlay in Google Earth. So you can see in all that time I just managed to pan from here to here. So let me show you some more stuff over here to the right, which I find remarkable.
Have you thought about adding a mechanism to kind of show where you've already panned? Like imagine you're, hunting for treasure and you want to know what you've covered already. So
that's a good question. So here, oh, you mean in the display itself?
Yeah, like seeing what you've covered.
So we haven't worked on that. That's an interesting idea. We'll show you a Where's Waldo panorama later on,
Okay.
and you'll see where it could be useful. So this is the Colorado River, and if we go over to the right here, you can see this is actually Phantom Ranch for anyone who's been down to the bottom of the Grand Canyon. So as we continued taking these panoramas, we noticed that in the funniest panoramas that there crops up fairly amazing detail. If I can once again get my mouse. So here's the Golden Gate Bridge. And you go around looking for stuff. And you find surprises like you can actually read the speed limit. Or we can zoom into this sign here and find out all sorts of interesting things about the bridge. Can you guys read that from the back? Here, I'll zoom in some more. That's a statue of the guy who designed it. And off here in the distance, for people who know San Francisco well, you'll know what I'm about to zoom into. Yeah, that is Alcatraz. So you end up taking these panoramas and being kind of surprised by what you find hiding in them.
Jeez, I'm surprised at how clean your stitching is.
So that's an early one. We're working on better.
Well, I'm an amateur photographer. I do this by hand all the time. This is not easy if you have a smart person guiding it.
Yeah, we actually have a Photoshop expert who kind of helped us with the early manual stitching that we did, but all the stuff you're seeing here is stitched automatically. Especially once you get to the hundreds of images, trying to stitch it manually is just not, that doesn't
White
work.
balance or exposure issues.
Yeah, so there are a number of issues there, but what we try and do right now is keep white balance and exposure locked between images so that we don't have to do the complicated kind of high dynamic range merging. But that's something that we're also working on.
I mean, on a cloudy day you might get away with some of that, but if you have a lot of dynamic range or other changes in the environment, locking exposures possibly not an option.
So let me show you something about the website that we're on. So this is a public website. We're up to almost 3,000 panoramas right now that people have been submitting to us, many a day. So our growth rate is significant. A number of them are taken with this device, and some of them are taken by photographers who are stitching together in Photoshop, kind of have their SLR and are very patiently taking a number of pictures and then stitching them together. One of the fun features that we added to the website is the ability to, when you kind of go through and discover something, to be able to take a snapshot and annotate it. So you can go and say, hey, let's look at what we found. So this is a skyline from Seoul. And let's click on this one snapshot, rooftop demolition. So we're going to automatically be taken there. Did I lose my nudge again? No, that's fine. There we go. It's kind of hard to see what's going on here, but this is an excavator, which is a little happier normally on the ground. But it's at the top of a building.
Soon to be on the ground.
Soon to be on the ground. Big crane put it on the top and said, "Okay, work your way to the bottom." And that's a little freaky. I would be a little bit afraid of falling over the side there. Okay. People started using this feature to tell stories about the panoramas that they took. So this is one. And we can go down here and look at some of the snapshots. This is Forbidden City. So we'll click on this. This is a very important building with 11 creatures guarding the corner of the roof. So apparently in the Forbidden City, it matters how many creatures you have on the corner. It tells you how important the building is. I see some nods. I don't know personally firsthand. So this is... once again, I'm kind of living vicariously through all these people who've taken panoramas. I've never been to Forbidden City, and yet I get to go kind of explore and see what people are saying about it. So here's that feature in the website taken a step further. This is a market in Guatemala, and there's just a lot of stuff to find here. Anywhere you look, something interesting is happening. Here are people selling rope. Pan up a little ways. See people dressed in all sorts of different ways. But what I find particularly interesting are the little snapshots that people are taking below here and kind of asking questions or are making comments. So here's a snapshot, which is fun. Way off in the distance, there's this white pipe kind of sticking up, and the question is this a soccer goal? And we'll go click. Here it shows that there's a conversation, so I'm going to click on that and go over, and we'll get the conversation that's kind of cropped up around this. Is this a soccer goal? Yes, that's a soccer goal. The market is probably only used on Sundays, and the area is used for playing soccer the rest of the time. So this is cool. So here's a mechanism whereby you can go and kind of engage the author of the panorama and end up in conversation about the things that you're going and exploring. So you're not only kind of going and traveling a little bit, but you're also kind of meeting the people there. This is one of the things that we're shooting for. So let me go through a few more of these quickly, and then I'll hand over to Ted. So this is a temple in South Korea. And during this festival, all of these balls were hung. And there are actually prayers written on each one. So you can actually zoom in and read the different things that people have written.
If you read Korean.
Yeah.
Yeah, it has your Hangul.
This is Hexham Abbey in England, and you'll see that there's it's a little bit dim, especially on this projector. I don't know if I can brighten that up. Hold on a second.
Is your video going mind if I turn off half the lights?
Oh, please. Is that okay if we turn off lights? Give me a second. I think that helps somewhat. Let me see if I have the color profile right for this guy. That's a little better. Okay. A lot of times you hook up to a projector and all the darks don't show up.
So those are the 4 parts of the cathedral? Exactly
right. So this is a full 360. And we can go zooming in, and you'll see this is a fairly large panorama. This is over a gigapixel. And what I find especially fascinating is the glass. And all the glass here is at this level of detail, so you can spend half an hour just looking at the windows. We've been working with a number of folks using the device. We've been in beta tests, so we have had a number of people sign up to use the device, and we've built 300 of them so far. We're building another 500 right now. We've been working with some journalists as well, and this is a panorama taken by BBC The World, and it's a panorama in Istanbul, and there's all sorts of interesting architecture here, but the story is actually about this very interesting thing that when you build something new in Istanbul and you go to dig out the foundations, you instantly have an archaeological site. No matter where you dig, there's something interesting there in the ground. So they're here actually documenting the interesting things that they're finding. It's a great story. I encourage you to go look for it online. So this is the skyline of Boston, and this is where people started to synthetically modify images. So I'm going to zoom in a bit, and we'll see kind of what got photoshopped in. Anyone recognize this gentleman? So there are all sorts of little fun nuggets and tidbits you can find when you start zooming in this panorama. Oops. Okay, 1 moment. So we have all these people doing these annotations of all the different snapshots, and it's really quite fun. So if you say search on the term clock or statue or something like that, you'll find all these little snippets in all the panoramas. So this is a clock written in Sanskrit in India. This is a courthouse. They're just a zillion here. I don't know how many we have on clock these days. But you find all the instances of clock that people have gone through and marked. And of course, I'm afraid that if we search for Waldo, that's the easy way to cheat. Because as soon as someone finds Waldo, they snapshot it, of course. So here we go. There's actually no effort to go find Waldo. And then let me show you kind of finally. Here's a panorama that was. It's not actually a panorama. It's a mosaic, which was not taken with this device. It was over 100 scanning electron microscope pictures stitched together into an explorable image of this ant. And the whole ant is this detailed. I've never actually been able to use a scanning electron microscope, but I feel like, playing with this one that I have control of one. So here's like a breathing hole. I just find this incredibly fascinating, the hairy feet. So we have another, I think I probably showed you about 15. We have another close to 3,000 on the site. I encourage you to go look. And we're getting a lot more as we go forward. So let me show you now how we can display these in Google Earth using the photo overlay. So if we bring Earth back over here. Let's zoom out a bit. And right now we have the preview layer turned on, I think. So this is one of the. Is that right? Okay. Here's a panorama that's turned on in the Google Earth preview layer. So if you just load up Google Earth, you'll see this. Click here, and you can turn on the rest of the layer. Right now we have about 100 of our 3,000 in the Google Earth layer. There are another 300 coming out in the near future, and we hope to continue rolling these out as we go. But let's look at this one in particular. This Cathedral Lake in Colorado, up in the Rocky Mountains. This one I especially like because you can see from it kind of the difference between what's in the panorama. So here's the panorama, and once again we kind of have this ability to zoom in. I think my machine is kind of slowing down here. And using this image pyramid, we're able to stream increasing levels of detail update to Google Earth, and that's the feature that Ted will be talking about in a little while. So all these panoramas do that. And let me kind of show you what goes on over in this corner. See, kind of our panorama ends here, and there's something poking out the top. What turns out, what's there is actually built into Google Earth. So let's go and turn our panorama off. We can turn it transparent and turn it off all the way. And you'll see this is the mountain that's actually already in Google Earth. This is the terrain map with the satellite or aerial photography draped on top, and we can kind of compare the two. It's like here's the lake, for example. Let's kind of zoom into the lake with the Google Earth imagery, and let's now turn back on the panorama. You can see the difference. So you see a lot of this very interesting kind of contrasting between what you can see from the top and what you can see from the ground, and it's a wonderful complementary system. I always found myself kind of looking at Google Earth, looking down and saying, what would it be like to stand there? And what we're hoping is that with the system and this device, we can let people do that. We can let people capture that and publish that. So I want to hand over to Ted. I'm going to take a moment to switch over the microphone, and Ted's going to talk about the feature that he implemented to allow our website to transform its tiles into the format that Google Earth needs, and a nice little interface in our website which lets you do things like locate the panorama and orient it so that it lines up perfectly like you saw there.
So we have these beautiful panoramas that we can put in Google Earth, and it's great because you can explore your world in many more ways. And we do this through, of course, blank slides and KML photo overlay elements. So if you don't know already, photo overlay KML elements are a way of presenting non-top-down imagery in Google Earth, as you saw. So everything what we normally see within Google Earth is, oh, that's cool, let's put a ground overlay and overlay the crime in Chicago over the city of Chicago, and red means please don't go there, and green's cool. But that's not all that you want to do to explore your world as well. So this allows you to put different imagery in, such as pictures that you see. One thing that you should notice is the GigaPans that you see, the panoramas you see from gigapan.org within Google Earth use a spherical projection. There are other projections available, which we'll get into, but just keep that in mind. And now we should just go into how these things are actually, coded up in KML to display in Google Earth.
Wasn't the one we just saw in a cylindrical?
That was actually spherical, but the vertical field of view was so small that it looked like a cylinder anyway, and it was pretty distant.
Okay.
So this is it. This was actually taken from the Golden Gate Bridge that you saw earlier with the cables and wonderful flag in the wind that I guess we didn't actually see. For brevity in this, you can put the standard description, name, all that fun stuff, and normal KML elements in there, but I took them out because it wouldn't fit on the slide, and, well, this is the cool part that you want to see anyway. So let's go in and see what the different stuff is for this one. You'll notice that this is broken up into a few different areas within here. Here we have positional elements, which basically describe where is our camera located and where is this panorama actually located within on the Earth. So the first thing we have is a rotation along with the camera, which specifies basically where am I sitting in space and looking. You have the standard lat long heading and all that fun stuff along with altitude, but you also have tilt and roll, which if you're not aware, let's take this to be, it's a camera. So we'll have a camera, we'll point it somewhere, and let's say that you're facing straight ahead. Tilt would be, essentially 0 in this case. Actually, not really, but okay, if you're pointing horizontal, you'd expect it not to be tilt. The way Google Earth actually thinks of this is as if it's pointing straight down, it's 0. So at the horizon, it's actually 90, and if it's pointing straight up, it's 180. Most panoramas typically point around 90. This one's 89, slightly 1 degree, if you can even tell the difference. But that's fun. And then we have roll, which, of course, if your camera's like this, well, that's rolled and really rolled and really messed up. So we can use this and basically just describe the full orientation within space. The rotation and the roll and the camera do slightly different things, but for the most part, you should keep them the same. We found that it really doesn't make a big difference, and for most stuff you do, you'll keep them the same. And we also have the point, which is at the very bottom, which basically describes, okay, where am I going to put the icon on Google Earth? Typically, when you zoom out, there's either a little camera or a place mark icon or something, and that's where that is, regardless of where the eye of the camera is and where the actual panorama is, displayed at. So then we get to move to the projection elements within this one, which include the view volume and that's actually and the shape. So the view volume, as you can see from the diagrams, basically it describes, okay, if I'm sitting at this camera and I have this image and displayed, what's the extent of those images as far as what you're going to see? If you imagine your camera is straighting and it's looking at a point, how far, what's the camera's field of view basically? And this allows you to specify it. The near is how far away from the camera you are. The left field of view is your left or my left extent and right extent, and the top and bottom are top and bottom. It's interesting to note that the bottom field of view is actually negative. You add them together, get the total, and also add them together, the left and right total. If the bottom was 0, that would mean that the bottom of your panorama is perfectly on the horizon. Typically, that's not the case. Typically, the horizon of your panorama is like midway, so you shift it down to make it look okay. And we'll get into that when we actually place a panorama later. Then we get into shape, which is, okay, what's the projection for this panorama? Now, we have 3 different projections here. We have rectangular or planar. Rectangle is actually the word you use within the shape tag to tell Google Earth. And that is good if you took like one big picture with a camera just sitting there. There's no tilt, there's no panning, it's just one square picture. Cylindrical is if you're panning but not tilting. So if the camera was fixed and you just went like this and took a bunch of pictures, that would typically be cylindrical because you have no other. And then spherical is, well, tilting and panning, just like the GigaPan unit with the camera at one fixed location. And using this, you can basically specify, okay, where is the image and what does it look like in the image in the Google Earth. So the second properties that we do is, okay, now that we've described where our image is and how it looks within Google Earth, where are the actual images that make this up, and what are the properties of the images so that Google Earth can say, oh yeah, I have a picture here and I should display it there. There's two things that goes into this. The first one is the icon, which is actually the fun part, kind of, because you get these wonderful, it's basically a URL. It's not really an icon per se, but it's a specially formulated URL that has certain tags in it that you can say, okay, Google Earth, when you're going to fetch a certain tile in my image pyramid, you should basically interpolate these values within the URL to get the real URL to my image. So the image pyramid, as Randy was alluding to, is basically, it's this. You have a base layer of images, which is your full resolution, and then as you go up levels, they're basically subsampled to less and less resolution. So as you get up to the top, you have one very small image, but if you get to the bottom layer, you have a lot of high resolution images. This is the same way, everything is streamed in Google Earth using pretty much the same thing, I believe. So the level is basically which plane on that image pyramid I'm on, and while the X and Y specify, okay, which coordinate on that plane am I on. You can basically think about it of X, Y, and Z being the level, but they use level because it's an image pyramid, and pyramids have levels. Yeah, so then we get into the other one, which is the image pyramid tag itself. This basically describes, okay, so we have this projection of our image within Google Earth, and we've described how to get to the images in our Google Earth, get to our images, but if we have a very small image with a very big projection, how big is the actual image going to be as far as pixels are concerned? So you tell it the maximum width and the maximum height of your panorama, and you tell it the tile size, which must be square and a power of 2, all documentation, and basically the grid origin, which is where is 0, 0 on my panorama. And typically, as far as GigaPan is concerned, these are 256 is standard and always using upper left. So, with that in mind, we really don't want people to have to edit this manually to place their GigaPans, panoramas in Google Earth, because that'd be really annoying. So we wanted to create basically an interface for them off the website to say, okay, we want to display this in Google Earth, and we want people to be able to do this, but very easily. And so we wanted basically to create a web interface to allow them to place their panoramas within Google Earth and tweak those parameters if they need to. And because we want them to be tweaking and make them look nice so that maybe they get in the Google layer, we want it to be semi-real time. And this is actually, it's possible. And as such, we will show you. Show you how it's done, I guess. It'll be fun. Let's get to it. Okay, so I need, oh, there's Google Earth for me. That's nice. Oh, that's up. Mouse button, score. Ooh, there it is. I am going to shrink these windows and basically get sizings okay, because I have to view a browser and Google Earth, and that just doesn't quite work out too well on the small screen. And we have this one. So the one I'm going to actually try to locate for you is one Randy took and when he left me for a week to go to Switzerland. Thanks, Randy. And yeah, ooh, maps are wonderful. Sorry. So we'll go to the list of his GigaPans. We'll say, okay, let's place this panorama in Google Earth. This will do magic, hopefully. Ooh, good. It did do magic. Sure. I don't know what that's going to do. Actually, it's just open with. That's cool. I hope that works. Ooh, it did work. Happy day. All right. So we should go to wherever this panorama is. Should have just, where am I? Oop, there's my mouse. Sweet. Gotta love this. And currently it's going to go to Mountain View, which isn't really, helpful since it's actually in Schilthorn, Switzerland. So what we will do is we will go over here and resize this window because we love resizing windows. And we'll say, okay, this is not actually here. Let's actually place it in Schilthorn. So we have this interface which has a map which allows you to place it somewhere on the Earth. And then we have down here different image properties that you would kind of find in the KML. I should probably move that over because you can't read anything, can you? Okay. Heading, elevation stuff. The other tags you might see in that KML. And if I could just find my mouse cursor, that would be great. Oh, there it is. And of course, we have advanced stuff for the image plane, and stuff, which gets translated into the appropriate tags. So let's go find my mouse cursor again. Oh, there it is. And we will go to that place.
So there aren't coordinates already associated with most of the panoramas you have?
So I would say that about half of them have been located. This one we've unlocated for the purpose of...
So we will zoom in this a bit. If my mouse will cooperate, it'll be awesome. And here we are at Schulthorn, I guess. And that is not exactly where we are, because we definitely have imagery available. Okay, and it's not actually there. We're actually over here a bit. And something's complaining at me, but I don't really care. So, in an ideal world, that would move, but it's not moving, so that's all good.
Save it first.
Pardon?
You get to save your...
No. The whole point of this is that it is in semi-real time, so as we move this would also move. But since it's not cooperating, we'll just ignore it and move on. So, if that would have worked, that would have been cool, but it didn't, so we're going to go back to our presentation and just skip it.
So, what's the updater talking to?
What is the updater talking to? That's a good question, and that is exactly what we're about to get into. So, what is that thing talking to? That is talking to the GigaPan servers. Right. So, assuming that we had geolocated it, how did it work? Basically, the simplified version is you make changes on the web page, they get pushed to the server, and then Google Earth's constantly pinging the server through that network link you saw, and then those changes are pulled to Google Earth from the server. And by the server, we mean the GigaPan server, the GigaPan website server. So how does that work? Well, pretty quote simple. Standard AJAX calls basically a website from that form you saw to the web server. That's stored on the server, and then they're pushed to Google Earth through that network link. Bit of a cool thing about the network link is it does use the new change tag, KML tags within Google Earth that was introduced with KML 2.2. If you're not up to date with the change tags, basically it allows you to update certain portions of an already loaded KML document on the fly without reloading it through a network link. So it's kind of a sparse update to your KML tree, so you don't have to reload everything, which helps if you have a lot of data loaded into Google Earth. We're also doing a little bit of trick with Google Earth and the server in that Google Earth is updating from the server. It wants to once a second, so we get approximate real time. But we don't want that to happen with many people because that would probably kill our servers quickly. So we're using this trick where we don't send any data to Google Earth unless something's changed, and we'll just stall for 10-15 seconds just in case something comes in, and then we'll push that change. But it really doesn't matter if something does or doesn't. We'll just then that's that. And yeah, so it's fun.
So basically, I just want to comment on what Ted said. He's basically invented a way to push data to Google Earth when Google Earth would normally be kind of in a pull model. So this is something that we found works really well.
And that is how we almost geolocated a panorama.
This is kind of a little publish subscribe deal going on here, where you've set Google Earth to subscribe to some information, and you're just poking the location. Okay, good. It's pretty cool.
So if any of you want to see that up here, we can set that up and show you.
So Pam asked a question about the coordinates. So I mean, these panoramas can be significantly large, right?
Mm-hmm.
I mean, is there any kind of projection you're making back into sort of lat long space to say, well, right here, like if I had my cursor and I just started moving it across, that you could sort of give me the lat longs, and how would you deal with depth in a two-dimensional projection as well? I mean, it's a
It's a very good question. So right now, at least at the website, we're not doing any of that. So we're not projecting onto a terrain model or things like that. So that's
well. I mean, for an example, let's say I have somebody who has a lat long point that they've waypoint they've recorded in some way, and they they're on holiday, and they go, hey, I want to show you where I was. Now they weren't smart enough to take their camera with them or lost it on the way home or whatever it was. They go to your site. They did save their geo points. They type in a lat long, and up comes this beautiful picture, and they go and that's me right there.
So
and
that's
that would be a
we
killer
haven't
feature.
done, but that's a great idea.
Yeah, I think it would be a killer feature.
Yeah, I like that. To kind of find all the panoramas that some.
Yeah, or like here's
that,
my sort of
given
rather
location
bland
is-
one
is,
photo, and I've taken
yeah.
it with my brand new camera that's got like a little GPS unit in it, and Bing, I look at the EXIF header and I say, boy, I bet there's a better one online. And again, they just sort of coordinate with yours, and then they sort of go, wow, I wish I had one of them damn GigaPan cameras.
It's interesting, actually, that now that I think about it, the scientists in the Mars mission asked for exactly the same thing. It's like they said, if I can identify this point in the terrain, you show me every single picture that's ever been taken that includes that point. And,
yeah, I mean, it has to do with, like, the camera looking down is sort of the Google Earth point of view, but people don't look down.
Yep.
Can you talk a little bit about the image pyramid? Because that, I think, would be something people would be curious to know more about. So, like, how the file system works and how the href identifies them.
I suppose. So we have this massive picture, Panorama, and basically it's very high resolution. So as far as the way we set everything up for Google Earth is concerned, they're arranged in a directory structure like level X and then y.jpg. So you have this massive directory tree, but we have to create this directory tree with all the different levels in X and Y. So we take this massive picture and we cut it up into tiles. These tiles are 256 by 256 JPEGs. And we take this and we subsample those for each previous layer. And then you put those in respective layer directories and chop those resulting images up into their 256 counterparts. And you keep doing this until you get down to one picture that probably doesn't fill up an entire tile, and you really can't see much of it or any sort of resolution in it at all. And that's that's level 0. And from there you can say, oh, level 1, well, it's bigger, and level 2 until you get down to level n and -1, I guess. And that's your full resolutions. And as far as the href are concerned, those different tags, Google Earth will then interpolate and say, oh, I know I want level 2, row 3, column 5. And so it'll say, oh, okay, let's create a URL. So it's level, well, that's 2/3/5.jpg. And then it'll go to the web server, and the web server will go, oh, yeah, I have a file right there, and it'll give back the file. And it sounds, and it's like magic, because Google Earth just works.
So I know that you guys already have this Flash viewer, but it seems that since you already have 256 by 256 tiles that are already following an XYZ scheme, it seems like it would only take a few minutes to actually go and make a Google Maps custom map type with these tiles. Have you hacked at that at all yet?
We haven't, but we're very interested to work on that.
Okay. I think it should work pretty easily.
Can you comment on what you used to do the chopping up of the image?
That's done either by the Stitcher, or we also have a separate upload utility available on gigapan.org that you can take your own big pictures and it'll chop it up for you as well. So,
and
yeah.
What does that use to do the chopping? Can you say?
Let's see. Well, Randy's uses.
Yeah. So so there are actually two different code bases that can do this. One is based on an open source library developed at NASA Ames called Vision Workbench, and Vision Workbench is able to do a number of image and vision processing sorts of things. But one of the things it can do is build an image pyramid. whatever resolution you need and whatever type of image. So you can say I want tile size 256 by 256 and JPEGs at 90% quality or whatever you want. It can output that. We have a second library which Ted built about a month ago that we're distributing to people. It's a much lighter weight than the Vision Workbench, and it's able to take imagery kind of in whatever order you can produce it. Like if you're reading a large file sequentially, you can like toss it in. If you have other things not coming in order, you can toss those in. And Ted's code will actually build you an image pyramid from the bottom up, and as tiles become ready, can either upload them to GigaPan.org or write them to disk or what have you. So that's something that's available from GigaPan.org. It's free software.
There's a Vision Workbench 2 just recently, right?
Yeah. There's a new Vision Workbench release coming out pretty soon.
Are you using that?
We're using it in the Stitcher, yes.
Did you find it a lot to wrap your hands around, or were you able to just use the part you wanted?
I love Vision Workbench. I'm biased because I help develop Vision Workbench, but it does a lot of. We had a lot of different machine vision types of projects going on at NASA Ames, and we were able to through Vision Workbench to kind of combine the code bases. And when one person gets bundle adjustment working, everyone can use it. So it's been a big help for us, and it's been really motivating for us to be able to make it open source. And so Michael Broxton and Matt Hancher are kind of the primary developers who've been working on it, and they've done just a remarkable job on it. I think. Again, I'm biased, just to be honest and upfront.
It's big. There's a lot there.
Yeah.
So if you just came to it cold, it'd be a lot.
Yeah.
Any questions? Cool.
All right. Well, thank you all very much.
Thank you, guys.